I want to welcome you to my lecture today. Of course, on Wednesday, we started analysis of covariance. And of course, today we're going to continue. Today's title is Uncover in the Presence of Violations. Okay, it's just like, what do we do if there's a violations? But before I go into today's, topic, I first want to appreciate those who visited me during my office hours yesterday, and those who asked questions, and those who actually asked questions from the TA. And what I've decided that I'm going to be doing from this, from homework 6 and above. So whenever I give assignment now, uh, I think the next day when I come into class, I'm basically going to review those assignment questions with you so that we are going to be on the same page. Okay, so your feedback actually helped, and I realized that at times questions may be very easy, but what if instruction is conflicting? I'm going to say that again. I realized that at times, questions may be easy, but maybe what makes question to be complex to students is because of the fact that instructions are kind of conflicting. And that is the reason why anytime I give assignment now, I'll be coming to class, the following day, I'm actually going to have a preview on that so that we're going to be on the same page. So because the feedback that I got from the students yesterday and the one that I got from my TA, it shows that students misinterpreted, situation where majority of the students have different interpretation, then that's a problem. Then it means, the instructor has set a difficult questions. So which I apologize for that. And that was why I extended the deadline by 48 hours. So in the outline today, I'm going to go into a quick review, tip on the assignment 5 before I go into, the lecture proper. Now let's look at the assignment 5 now, just like what I said. I'm basically going to be reviewing assignment with you from today, anytime I give assignment so that we can be on the same page. Now, but let me make this clarification. At times, we may see a question, maybe it may be random effect, but what if examiner said, set it to be fixed? At times we can actually ask you to okay, we know it's this, but run it to be this. Now, because of that, I'm going to make this clarification, and I can see students normally confuse randomized complete block design with two-way analysis of variance. We have a two-way ANOVA, right? And we also have, for instance, one way with blocking restriction. Do you know that these two are not the same? If you look at question 1 here, if you specifically look at what they ask you to test, I got that from here. If you look at that, it said, analyze this data to determine the effect of location. What does he emphasize on? Effect of location. But that doesn't mean there is no laminate. But the laminate here is basically going to act as a block effect. So which means I'm still talking about one-way analysis of variance with blocking effect. So which means you're going to test the effect of location, you're going to test the effect of laminate, but we're not that interested in the effect of laminates in problem 1. But what is the essence of the testing blocking effect? It's just to see whether we have homogeneous area or heterogeneous area. Any question on number one? Any question on number one? Now, another thing I want you to take note. When you look at location here, you can decide on whether you're going to take that as a treatment, as a fixed effect or a random effect. And what do I mean by fixed effect? What do I mean by random effect? The difference is just like for the random effect, levels are chosen at random from the population. Now, take a look at, in this experiment, 7 laminates are chosen at random. Automatically, the blocking effect here is random. Even though we're not interested. We're not that interested. It's not as if we're not that interested, but the primary variable of interest is location. Any question here? Any question? So which means this is a randomized complete block design. We are focusing on one factor, location, with a blocking effect. Any question? You're all good, right? With number one. Okay. Now I want to go into problem 2. If you take a look at the problem 2 now, the problem 2 is now considering two-way ANOVA. We're no longer talking about blocking effect anymore. We're talking about two factor. Factor A, factor B. And that was why I said there's a difference between, in fact, when you go to some textbook, I know some textbook may say, oh, one-way ANOVA with a blocking effect is two-way ANOVA. That's okay. But what I just want to know, when you have two factor and one is the main factor, the other one is just a blocking effect. I'm just going to call it a one-way with blocking effect. Because the interest is still going to be on that same factor. But when you take a look at problem 2, I'm no longer talking about blocking effect anymore. I'm talking about two-factor experiments. Factor A, factor B. And I specifically said set location as fixed and set laminate as random. I'm not supposed to say this because we already know location is fixed in the question and laminate is choosing, and that's why it's random. And somebody may now want to ask, what is the difference between this and this? Between problem 2 and problem 1. The difference is just like in problem 1, we're focusing on location where the location, laminate is a blocking effect. So that by the time you are interpreting, even though you may get the same result, problem 1, problem 2, but the way you go to interpret problem 1 is different from problem 2. In problem 1, your focus is on location, while you only want to see whether the blocking restriction is significant or not. But when you take a look at problem 2 now, you have two major factors, factor A, factor B. And some of you have asked me, do I need to consider interaction here? Of course, no. Why? Take a look at the data architecture. We have one observation per cell. Interaction will never work. The only condition under which you can consider interaction is when you have at least 2 observations per cell. If you look at, say, location 1, laminate 1, we got 28, right? That is 1 observation. And you have 1 observation in each cell. The idea of interaction is out. So which means what you basically want to talk about here is just like two-way ANOVA without interaction. Now, if you take a look at 2A, 2B, 2A, the difference is just like in A, use the classical method. Don't forget, when you use the classical approach in 2A, you're going to perform algebra, because classical method will never come with variance estimation. But 2B, you are using an approach that will come with the estimate of the variance. And that was the reason why we, in question C, I'm asking you to compare the results in using both classical and the restricted. Go ahead. That's a very good question. We did not ask that in this, but if you are doing your research, independent research, then you need to investigate for assumption. That's a good question. But if I've stated it as part of the instruction, then you can actually go with the assumptions. That's a good question. I love that. In fact, send me a message for extra credit for asking that question. Okay, now G, compute the ICC. You know, I've already deleted something because a lot of students ask me that question. When you compute an ICC, that's a correlation, right? What if I now say, what is a percentage contribution? That is like multiplying ICC by 100%, by 100. That's simple as that. Okay. Oh, which is what I asked in question E. Determine percentage of variation attributed to random component. Why do I say random component? Because all my factors are not random. This is an example of a mix, right? A factor is fixed and the other factor is random. Of course, it is only a random factor that we have a variance, right? A fixed factor does not have a variance. Any question about problem 2? Any question? Problem 2? Any question? Okay. Now, okay, then I ask question about F. Okay. What is location? Location, what did I say is fixed, right? Do you know that when you use restricted or maximum likelihood, it's going to give you result of both fixed and random, isn't it? If you check, it's going to give you both result for both fixed and random, because we also use restricted maximum likelihood for mixed effects, not only for random effect. When you use it for random effect, you're only going to have variance. You are not going to have fixed. But when you use it for mixed effects, it's going to give you two-way output. One is going to be on fixed, the other one is going to be on random. Does that make sense? So I think all this should be clear now. And another contextual question is I. When I say if you have to design a future experiment to investigate the laminate factor, okay, will you include or not a location as a block? Now, you know what you know what you did in problem 1? In problem 1, you take location as a location as a main factor, while laminate as a block, right? I'm now saying, okay, can you think about this? Is a practical question now. Switching that, where this time around, I want to take a laminate as a main factor. Can the location be considered a block? It may be yes or no, provided if there's a significant, if you get a significant result in the location. If the location is significant, then it means location is needed to be a block or in that particular model. Now, I'm going to problem 3. In fact, I receive a lot of questions on this problem 3. You know, students, they have been asking me, oh, is this a fixed? Is this a random? It is not. I want you to take note now. It is not all the time. This is not the only criteria to identify whether a factor is random or not. Like, I know what students normally look into is, do they mention is choosing at random? What if they did not mention that? I'm going to tell you another way to identify a random effect. If they only talk about variability. Hello? Anytime you hear variability, then you should know they are interested in the variance. When the interest is on the variance, that should be random, not fixed. Look at this question. The data are collected in Davis and Goldsmith as coming from an investigation to assess the variability. Variability, look at that. And do you know, which means the factors that they are talking about here, they should be random. Because we're not interested in comparing means, but the interest is on variability. I told you the other time, when you are investigating random effects, we are testing the variance. Okay, now take a look. And in fact, I even gave a clue. Look at the code that I gave. You should be suspecting something. When I said load LNE4, even without giving you that clue, anytime they mention variability, if the interest is on variability, even though they did not tell you how the levels of factor are choosing, then you should know that factor should be random. Any question? Okay. Now, and that was why even there's something here that you're also going to see in the question that they focusing on variability. They say analyze this data set to determine which factor, sample, or plate contribute most variability to the diameter. Look at that. It means here the sample and the plate, they are random factor, because the interest is on investigating their variability. We're not investigating the quality of the levels of means here. And I also said, how much variability does this factor contribute? Of course, it's a random effect. And I said, can you include the sample by plate interaction time in your model? That now depends on your data architecture. Do you have one data point per cell or more than one data point per cell? Does that make sense to everyone? Does that make sense, right? Okay. The last one is the problem 4. I wanted to take a look at, I also receive a lot of messages from students about this, but I love your messages. Keep sending them to me. Keep asking me questions. You deserve to ask questions. You pay for the service. Now, a company wanted to replace the machine used to make a certain component in one of its factories. 3 different machines were available. Oh my God, take a look at that. 3 different machines were available. That is the only thing. Sincere employees, but they only selected 6. Of course, that should be random. If I gave, now you already know in this question now, machine is fixed, employee is random. But do you know in this same question, I can ask you to set something that is fixed to be random. And I'm gonna show you something now. Look at question C. What did I say? I said, for the remainder of this problem, assuming machine is a random effect. But what did you see in the question? Is it random? Did they say random? I mean, it is fixed in the question, right? Because 3 machines were available, but I've already directed you that, okay, because you need to follow because I know some students, they were like, they asked me question, they said, but in the question, the machine is supposed to be fixed. But I said, you know what? You need to follow instruction here. I think I said that for the remainder, I know machine is fixed, but I want you to set it, to be random. Let us act as if we have more than 3 machines and we only choose those 3 at random. Any question? So at times, And that's why instruction is very, very in any exam. You know, a student will stand a you know, better chance of passing exam when they follow instruction. Does that make sense? Okay. Now I want to go into today's